Hello, in this video, we're going to discuss on how to find the eigenvalues of certain matrix. For example, we have this matrix L, and our task is to find the eigenvalues of this one. So for us to be able to do that, we need to use these determinants of A minus lambda I. So this going to be your L there. So what we're going to do is this L, I'll just write down this L, no matter what is it, minus lambda, oh wait, sorry, I think it's better if I will write that one. Negative 11, 8, 16, 3, negative 2, negative 6, negative 6, 4, 9, minus the lambda of your I. Since this is a 3 by 3 matrix, so therefore, our I should follow that dimension or that size. Oh, sorry, 0, 1 there, right? Like that. And then we need to find the determinants of that. We need to find the determinants of that, right? So, negative 11 minus lambda I. So, we're going to have negative 11 minus lambda, 8, 8 minus 0, 16 minus 0, 16, 3 minus 0 is 3, negative 2 minus lambda. So basically you just need to minus lambda for each diagonals, right? So that is a 9 minus lambda. There you go. And then after this one, we will try to find the determinants of that and make it equal to 0. So the determinants must be equal to 0. And how shall we do that? We need to get the cofactors of this. So for us to be able to find the determinants of that, remember here, this is going to be your plus, minus, plus. So there are many ways to find the determinants of this one, but I usually use the one on the top. So let's just focus into that. And we need to follow this one. So initially it says plus negative 11 minus lambda. So we will just make it negative 11 minus lambda times the cofactors of this one. So how would you get the cofactors? You cover that one. Sorry, it doesn't work there. Okay, never mind. So you cover that, and then you also cover this one. Then the entries that remains is the cofactors. So that's going to be, or I think it's better if I will just write it down first. So negative 2 minus lambda, negative 6, 4, 9 minus lambda. And then minus because of this minus sign here. Minus 3 times the cofactors again. So you cover this part, you cover that part. So you will end up with 8, 16, 4, 9 minus lambda. Then after that is minus 6. Again, we're just doing this one, okay? Minus 6 of the remaining cofactors, which is actually 8, 16, minus 2 minus lambda, and minus 6. So there you go. Alright? Now, then what are we going to do is just simply get the determinants of this. And what is the determinants? What's the determinants of this? That is actually this minus that. So let's try to do that. So this gonna have, this will be what? One moment please, let me just check the screen. Okay, so far so good. So this is gonna be negative 11 minus lambda times, this one is what? Negative 2 minus lambda times 9 minus lambda minus, okay, this is negative 24, so therefore it becomes plus 24. And please don't forget that that is times that one, okay? And then do the same thing, minus 3 times 8 times 9 minus lambda, 8 times 9 minus lambda, then minus 16 times 4 is 64. Alright, then minus 6 times this one. 8 times negative 6 is negative 48. Then minus 16 times negative 2 minus lambda. So, there we go. Again, don't forget that is times 6 of that. Oop, why did I put the green one there? Well, anyway, so this is now, and that will be equal to 0. So that is of the determinants of this matrix A, right? Or the determinants of your L minus lambda I. And then you need to simplify that. When you continue to simplify these, you will end up, okay? You will end up with, I'll not do this one by one because it will take us a long time. But when you simplify that, you will end up with something like this. Like lambda minus 1 times negative lambda squared minus 5 lambda minus 6. So all you just need to do is to simplify that. And then you will see that you will end up with something like this. Okay? And then after simplifying that, and that's equal to 0, so here we can see right away that lambda is equal to 1. And then lambda minus 1, we can factor out this. And the factors of these are lambda plus 2, lambda plus 3, like that one. And that's equal to 0. So therefore it will give you the lambdas to be equal to 1, lambdas equals negative 2, lambdas is equal to negative 3. And there you go. These are the eigenvalues. These are the eigenvalues of your L. That is the eigenvalues of this one, of this L. Okay? So there's a follow-up question here, like show that this is an eigenvector corresponding to eigenvalues L, and find an eigenvectors corresponding to the other two eigenvalues. Alright? Now, I just want to look at before we proceed to that problem, I just want you to look at this one. That here, you have a 3 by 3 matrix. And the 3 by 3 matrix, the maximum number of eigenvalues is actually 3. 1, 2, and 3. Right? Now, so I'm gonna pause this video for a while and then just watch the next video on how to find the eigenvectors. I will continue the same problem in the next video. Thank you.